Hello, in this video we will be doing example 1 from lab lesson 2A. So here's a multi-view drawing of the part that we'll be modeling, and looking at this part and the different views that we have, we can see that this part has a cylindrical base with a tall cylinder on top. So we can see this in the front and right views, and we can see the circular profile in the top view. The tall cylinder has a hole in it. We see in the top view that it has a diameter of 40 millimeters. And looking in the front view, the hidden lines show us the extent of this hole, which shows that it extends down to the top face of the rectangular feature of this part. Finally, there are rounds on the ends of the rectangular feature. We can see these both in the front view and in the top view, also in the side view, but it's a little less clear. And the tall cylinder also has a round applied to it as well. So those are the general features of our part. The center lines on the front and right views indicate the cylindrical axes of this part, but they also represent planes of symmetry for the rectangular feature. This is seen in the top view as well. So even though we are only given the rectangle height and width from the center mark in the top view, we know that the dimensions are the same on either side of the planes of symmetry that we're given. So now that we have this information figured out, how do we model the part? Well, our strategy could be something like follows. First, we can use the Revolve tool to generate the cylindrical features, so that's the base cylinder and then the tall cylinder on top of it, including the hole. We can essentially sketch half of the profile we see in the front view and then revolve it around the axes for those cylinders. Once we have that done, we can then use the Extrude tool to create the rectangular feature. And then finally, we can apply our rounds. So let's get started. I've opened up Autodesk Inventor, specifically a standard millimeter part file, since this part is dimensioned in millimeters. And the first thing I'm going to do is start a 2D sketch. I will start it on the XY plane, which corresponds to the front view, and I'm going to sketch out half of the profile of the cylindrical features that we see from the front view of our multi-view drawing. So I'm just going to use the line tool for this. I'm going to start at the origin. As usual, that eliminates some of our degrees of freedom. And I'm just going to sketch out the general shape of our 2D profile that we want, which looks sort of like an L, but there's going to be a little bit cut away from it to represent the hole in the top cylinder. And there we go, we end up with something like this. So you'll notice that Autodesk Inventor automatically applies geometric constraints. These are all perpendicular constraints for my lines. We also have a horizontal line here, and that's handy because that further constrains my sketch. So now I can click OK, and all we have to do is dimension this sketch. So I'll use the dimension tool. We can see in the front view that the height of the tall cylinder from the very base of our part is 110 millimeters. We can see that the height of the base cylinder of our part is 30 millimeters. And finally, we can see that the extent of our hole goes to the top face of the rectangular feature, which is 30 millimeters above our base cylinder. So I'll add that in as well. So now we have 3 dimensions remaining. I'm just going to rearrange this, or try to. There we go. So it looks a little neater. So you'll see that all of these lines are still purple. I can drag them about, and these are the degrees of freedom remaining. So I essentially have to constrain the radii of the whole feature, the top cylinder and the base cylinder. And I could do that with the dimension tool. I could dimension from the center line of these cylinders out to their edges and dimension the radius. But you'll see in our drawing that we're not given the radii, we're given the diameters instead. So rather than dimensioning the radii, I'm going to do something different. I'm going to draw a line on our sketch, and I'm going to draw this line down the center axis of our sketch. So you saw in our previous video that we can change lines to construction lines to help us sketch things out. I'm going to change this to a center line, and now we can dimension from this center line. And when I dimension from this center line, it's automatically going to dimension as a diameter rather than a radius. So now I can go ahead and enter in the dimensions that we got straight from our drawing. So 120 millimeters for the base cylinder. For the tall cylinder, we have 70 millimeters. And then for the whole feature, we have 40 millimeters. So I'll add in those dimensions. And now you can see our sketch is almost fully constrained. We have one dimension left. That just happens to be the height of this center line, which really isn't too important for the profile. Our profile is fully constrained, but just to be complete, I'll dimension the height of this center line, and I'll just make it equivalent to the total height of our part. So before we saw we could do arithmetic in our dimensions, like I could put 100 plus 10 millimeters and Autodesk Inventor would figure that out. I can also reference other dimensions. So if I click on this 110, you'll see that now my current dimension, which has the variable D6, is going to be assigned the same value of dimension D0, which is this 110 right now. So I can do that, and you'll see my dimension is currently 110 millimeters. It's a function of the previous dimension. And now my sketch is fully constrained. So I can finish this sketch and zoom out. And now we can revolve it around the center line. So I'll use the Revolve tool. It's automatically going to select my closed 2D profile to revolve around. And since I have a sketch with a center line in it, it will also automatically select the center line as my axis of revolution. If you don't use the center line, if you just dimension the radii instead, then you would just have to select the one edge of your sketch to be your axis. That's all. So you'll see in this tool, we can also pick the direction and the angle around which we want to revolve our profile. This is already set to 360 degrees, which is what we want. We want it to go all the way around. And because it's going all the way around, the direction doesn't really matter. So we can click OK. And we have the first base feature of our part done. You'll see it shows up in our model browser as Revolution 1. And if we want, we can change the name of this by just double clicking and typing in, let's say, base revolution as our name. And this is one of our solid modeling best practice tips. If we label all of our features or name all of our features in the model browser, this will make it easier to document what we're doing, and it will make it easier to go back and edit features if need be. So now that we have these cylindrical features down, we can go ahead and sketch out the rectangular feature for extrusion. So I'm going to start a 2D sketch. I could start it on the same plane that I did before, which was the XY plane, but I'm actually going to sketch it on the top base cylinder. So I'm going to start a 2D sketch, and we know that this rectangle is actually centered on the axis of these cylindrical features. So rather than using this 2-point rectangle, which is the default in Inventor, I'm going to use the 2-point center rectangle, which allows me to start my rectangle at its center point and then drag it outwards. And that's handy because I can automatically select the origin in my sketch, which happens to be the center point of these cylindrical features, and I can then drag it outwards. So this is perfect because it automatically reduces the number of degrees of freedom since my rectangle is now centered on the point that I want it to be centered on. So now we just have to specify some dimensions. We know that the distance from the center point to one edge of our rectangle here is 30 millimeters. So we can add that in. And we also know that the width is 115 millimeters from the center point. So this automatically makes our rectangle symmetric about the planes of symmetry that we saw in the multi-view drawing, which is really handy. And now our sketch is fully constrained. So we can finish this sketch. And now we just have to extrude it upwards. So it will automatically select my closed 2D profile. And we want to extrude it upwards 30 millimeters, as we see in the front view of our multi-view drawing. So we'll do that. We'll press OK. And just like before, I can rename this extrusion. So we can rename it rectangular extrusion. And the last thing we have to do for this part is add the rounds to the top edge of this tall cylinder and to the ends of our rectangle. So I'll use the fillet tool for this. We're supposed to add a 10 millimeter round on the top edge of our tall cylinder. So I'll click the top edge and apply that. And then if we look at the rectangle, we can see that there is a 15 millimeter round. It's indicated in the top view of our multi-view drawing, R15 tip. And we can see this round from the top view and from the front view and from the side view. So in order to get our part to match these views, we actually have to apply a round on all four of these edges. for one side of our rectangle. And again, the radius is 15 millimeters. So this will now correspond to all three views that we see. I'll click apply. And I could have selected the 4 edges on the other end of my rectangle at the same time to finish off the part, but I didn't do it in this case because I wanted to show one more tool, which is the mirror tool. So the mirror tool allows us to copy features about some mirror plane to replicate them on the other side of the mirror plane. So in this case, I want to copy the fillet feature that I just added to the rectangle. My mirror plane is going to be the YZ plane, so I'll select that plane. And then I just click OK, and you'll see it automatically mirrored those fillet features onto the other end of my rectangle. And with that, we finished our part.